Hello friends, in continuation with the last lecture, we talk about the last lecture about corrugated diaphragm and the bellows. Now in this case, we are going to talk about the another thing that is a Bourdon tube. In general, there are three common types of the Bourdon tubes are there. Okay, so you can see the schematic of the representation of the Bourdon kind of the tube over here. So this is the blue shading represents the Bourdon tube here. Okay, now the actually there are three common types. One is the C tube, you can see over here, then the helical tube and the spiral tube. These tubes are fabricated with metal alloys. Nothing but the two metals are just formed mixed together to form the material called as the alloy. So, such as the cold worked brass, phosphor bronze, beryllium copper, stainless steel, and nickel alloys. The most common type of the Bourdon tube is the C type, and in the most of the cases it is used a very useful kind of the tube or the type of the used in case of the measurement of the pressure. Okay, this instrument is an oval tube shaped of to resemble the letter C. We can see from this figure as well. Now, how it is just working here? That is the one of the end of the tube is open and the other end is fused and sealed, and obviously that the end which is sealed, which is free to move. Okay, sealed is free to move, and the other end is open, where we can attach the where the pressure is going to measure. The open end is attached to the frame, or in the case of the transducer, and the pressures to be measured is applied. So input is given to the open end of the tube, and the sealed end is kept free to move. After the application of pressure, obviously this tube will start to strengthen itself because of the pressure is coming from the inside, and obviously the tube gets strengthened, and or else if suppose the pressure getting decreased, then obviously the tube gets strings. Okay, strings slightly. So this mechanical response is related to the pressure formula. We know that the pressure is nothing but the force per unit area. Since the outside surface of the C tube is longer than the inside air, we can see over here that if suppose this, if you consider that this outside surface of the C is a longer one, and the inside surface is you can say that little bit shorter, the smaller one. So the outside has a greater area. Consequently, the force exerted on the outside surface is greater than the force exerted on the inside, causing tube to the strengthened one. So here, if area is more, then obviously the pressure will be the required more, and the or the force will be required more to have the same kind of the pressure. So here the force exerted on the outer surfaces is greater than the force exerted on the inside surface, and which causes the tube to strengthen. As the tube gets strengthened, the sealed tip or the sealed end will move, and the angular deflection of the free end is taken as a measure of the pressure changes. So the angular displacement of the pointer, which is just moving over the calibrated scale bar, is considered as its pressure measurement. So the pressure changes. The advantages of this type of the tubes are is that it is a very high sensitive, and repeatability. We can repeat them over large number of the cycles. The scales on the dials of the some pressure gauges include the readings below the zero as well. These gauges are referred to as the compound gauges and are often used to indicate the vacuum. The Another kind of the tube we are going to see is the helical type of the Bourdon tube. Is an oval tube, okay, is oval tube, and that is wound into the helix as shown in the figure over here. So we can say the helix type of there the large number of the turns are there, and obviously similar kind of one of the end is open and the other end is a fixed one or the sealed one, and it is movement is attached to the pointer, and pointer is just moving over the calibrated scale bar from the minimum to the maximum free and tip or the free to move. Uh, its shape resembles a coil. It operates on the same principle as the C tube, except that it is coiled into the multi-turn helix. From the turns can be carried from the 5 to 10 turns. One of the end of the tube is closed and is free to move. Okay, so this end is closed and free to move. On the other side, other end is open and is firmly attached to the pressure transducer or the transducer case or the frame. The pressures to be measured is applied through the open end and causing the tube to try to uncoil, okay, or unwind, and the tip of the tube moves in response to the movement of the coil caused by the pressure. Pressure increases, the obviously coil get unwind, and then it will just move the pointer in the what we can say in the to the maximum scale bar or in the positive direction, and if the coil gets or the pressure gets reduced, then the coil gets wound, and the deflection is on the reverse direction happens there. So the advantages of the helical tube is that it produces the more tip movement than the C tube. In now, what is the advantages of this kind of the spiral kind of the tube is that it produces the more movement than the C tube. Now the another kind of the transducer or the tube is used is the spiral tube transducer. The oval tube again, and is wound in a spiral in the spiral one. It was the earlier was the what we can say the helical path was there, and here is the spiral one in the circular path. And as we go in the outer side, then obviously its radius goes on increasing. So the tip of this tube produces the more motions than the other two tubes. The radius of the curvature increases with each turn. The tip travel due to its multi-turn configuration increases depending upon the number of coils. So that it depends upon the how many number of the turns are used, or the coils sorry, number of turns in the coils are used. These are the such kind of the uh, spiral tubes are used in case of our not in case of measurement of the pressure, but in case of the millimeter or multi millimeter and the voltmeter analog meters, such kind of the schematic is used for the measurement of the current or the voltage. The deflection of the Bourdon tube varies with the ratio of its major to minor cross-sectional axis, the length of the tube, radius of the curvature, difference between the internal and external pressures, and the angle of the twist. So, it also varies inversely to the modulus of elasticity of the material of the tube and the wall thickness of the tube. Uh, for a C type and the helical Bourdon tubes, the angular deflection can be expressed as this formula, that is theta by theta 0 is equal to 1.16 PR square upon TEB. Here, the theta is the angle of rotation of the tube. Theta 0 is the angle of the tube for the C tube, or the total angle of the helix for the helical tube. P is the pressure, E is the modulus of elasticity, T is the thickness of wall of tube, B is the minor axis of the tube, and the R is the radius of the curvature. Bourdon tubes are more sensitive to the shock and vibrations than the diaphragm, and therefore more used mostly in the static measurement. The range of the pressure measurement varies from 10 raised to 6 to 10 raised to 8 pascals. The advantages of the Bourdon tubes are their low cost, simple construction, high accuracy, and repeatability. Thank